Round of applause for Andrew, who's going to talk about Eventmachine.
Is this working? Yes, awesome. Hello. I'm going to speak about Eventmachine and whether it is a worthy alternative to Node.js. My name is Andrew. I'm Andrew on GitHub. Suck on that, all the other Andrews in the room. And tbass on Twitter. I work at Forward, forwardtechnology.co.uk. Pretty awesome place to work. And I've been playing with Node.js recently. I've been a Ruby developer for about 5 years now, mainly working with Rails. And Node has kind of started to seep into Forward. People building small applications here and there, just trying it out, and kind of piqued my interest. So I thought, let's have a look at this and have a play around with it. And so Node.js is evented I/O for V8. It's written in JavaScript, and it's designed so that you can write concurrent, scalable web applications or any kind of network application, really. It specifically designed to build HTTP applications, and you write Node applications in an asynchronous evented style. So what kind of things would you use it for? People use Node at the moment for things like chat applications, working with streaming services like Twitter, where there's massive amounts of data, and other real-time kind of applications. We use Node quite a lot in Forward for proxy services, where you're essentially either driving traffic through the application and using it for logging at massive scale, or using it to proxy other APIs and passing some data through to it. And another good use for it is to build web APIs on top of an existing application, because it can handle really high levels of concurrency. So talking about the asynchronous kind of evented nature of Node, but how is that different from normal Ruby applications? So when you have a synchronous web application, say like a Rails app, as soon as you write out to I/O, say disk or network, then your application blocks. It sits, it waits until the I/O is complete, and then continues. Asynchronous application will call out to I/O and then start carrying on working on whatever else it was doing. As soon as the I/O is finished, it will trigger a callback, which will then kick in and start working, which means you can utilize CPU much more efficiently because you're not waiting. I would guess 90% of your application time that it's actually running is spent waiting for I/O, especially with Rails apps and similar kind of projects. But one side effect you can get from using this style of programming is callback hell. This is an example from the native Mongo driver in Node to do a simple query written by one of the Tom Stewarts. And yeah, it's not particularly nice to look at, easy to understand, or maintainable in the long term. So we already have asynchronous framework in Ruby that's been around for about 5 years now, and it's called Eventmachine. It provides evented I/O for Ruby. So you can write similar kind of applications in an asynchronous style with callbacks when your I/O is complete, but written in Ruby rather than in JavaScript. What would you use it for? Kind of the same things. Real-time applications and proxy servers, yeah. PostRank, who have been kind of influential in in the event machine space recently have been using it a lot for web APIs and working with streaming data from social networks and things. And they've produced a library at the start of this year called Goliath, which is a asynchronous web server, similar to kind of Node, but also it implements the Rack API, or it's similar. It's not 100% compatible with Rack, but it is in a very similar style. So it's stuff that you're already used to if you've been working with Rack. It also supports Rack middlewares, or at least the style of Rack middlewares, so you can build up small modules of kind of pieces of your application, which then you can combine to produce the full stack without having to write it all out into the same kind of callback wrappers that you might do with Node. It uses Ruby fibers with EM Synchrony to actually push your asynchronous I/O callbacks into a new fiber each time any I/O is going to happen, which means that you don't actually have to write the callbacks yourself. It will, as soon as the I/O is finished, the fiber will then go back and continue working, which means you end up writing code that doesn't look asynchronous, but acts asynchronous automatically, and a lot more Ruby-ish. And it runs on Ruby 192, JRuby, and Rubinia, so it's quite agnostic to what you're running it on. So I like Node, and I like Eventmachine, but which one's better? So I've written up some demo applications in a number of different styles so that we can compare and contrast and do some performance tests to see how they run. First of all, some Hello Worlds. It's on GitHub if you want to check them out. First of all, let's look at what we're currently kind of working with, which is the basic Rack Hello World. You just return an array of the status code, some headers, and the body. Very simple, and you just run that with rackup. The Node.js example is JavaScript, so there's semicolons everywhere, and a little bit harder to read. You also have your code within the callback of creating your server. This is the raw event machine example. It's quite a lot more verbose than both the Node and Rack examples, but that is kind of the minimum you need to make a HTTP server in Eventmachine. And here is the Goliath example. You notice the similarities with Rack. It's almost exactly the same, as you can see here. So I ran some performance tests against these basic Hello World apps. And this is the kind of numbers that we're looking at. What surprised me here was that Eventmachine's Hello World was actually faster than Node's when I was using Apache Bench on my MacBook. But these numbers aren't really representative of the kind of performance you would be getting, because we don't have any I/O in these examples, so there's no real point in using an asynchronous framework if you're not going to be writing out at all. So I built some URL shorteners. They're all the rage these days, Bitly and that kind of thing. So let's have a look at some of these examples. So the code's a little bit small, but don't worry about the details too much, but kind of to have a look at the overall shape of the application. As you see, everything is a callback, and I'm using the connect router here, which is a library that kind of adds some middleware and Rack type functionality to Node, making it a bit easier to work with. Here's the raw Eventmachine example. Again, pretty verbose, and Eventmachine doesn't have a router built in, so I'm actually just looking at two routes here and switching on a case statement, which is not something you would really do in a production environment. But it gets the job done and easily ran on any system. And then here's the Goliath example, which is quite frankly beautiful. This is using the rack URL map style of setup where you have one application which simply maps other applications onto URLs. You can do this in rack as well. Incidentally, I skipped rack in this real-world example because it was just too slow and didn't really provide much use. The rack example would look very similar to the Goliath example. So let's look at the performance of these applications. Similar test. We're hitting a URL that will redirect us on after reading the target URL from a Redis database. So Goliath is actually quite a bit slower than Node here. I think that is because of the context switching out to Ruby fibers and back again, whereas Node keeps everything in just a single V8 instance. And what's really surprising here is how fast the Eventmachine example is. Much faster than the Node app, and can handle many more concurrent requests. And that really surprised me. I was fairly sure that Node was going to come out as the fastest of the three when I started putting these slides together. But performance isn't everything, and I think as Rubyists we all know that there's more to code than just how fast it runs. We might not be using Ruby if we thought that. So when it comes to testing asynchronous code, it's not as straightforward as normal testing. With RSpec and test unit, it expects your code to run in a synchronous manner, one step after the other. But when you're writing asynchronous code, you can never be sure if your callback is going to happen when you expect it or not. There's a couple libraries, one for Node and one for Eventmachine, which kind of help RSpec to, you can write examples that where you specify what your callback should come back with, but not when they should come back. So you kind of end up writing RSpec-like code, but it wraps up the kind of asynchronous callback thing so that you don't need to worry about the callback hell and the fact that it is going to happen at some point rather than it's definitely going to happen at the next stage. Another thing we love in the Ruby world is DSLs. And we know that Sinatra is a lovely DSL and has inspired a lot of other frameworks, including one for Node called Express.js. As you can see, kind of similar. I've also added the CoffeeScript version underneath, which if you're writing CoffeeScript ends up being much nicer to look at. I'll get to that shortly. And there's also another DSL for Eventmachine called Cramp. And Cramp takes a similar style to Sinatra, but this is built on top of Eventmachine directly. So this is all happening asynchronously, and you'll get a similar kind of performance to Goliath, but writing a much nicer kind of readable application. Another thing to consider is library support. Node is about 2 years old now, and it's got a fair amount of libraries available for it. There's probably a driver for every database you can think of. And there's also a really nice package manager called NPM, which doesn't stand for Node Package Manager, by the way. It's very odd. Of course, in Ruby land, we have Ruby gems, but Ruby gems don't always work with Eventmachine. You need to be sure that the code that is inside of those libraries is suitable for using with an asynchronous style of programming. If any of the code blocks when it goes out to I/O, then you'll end up getting a massive performance degradation in your application. So you want to look for libraries that usually they're named em star and will have nice compatibility layers with Eventmachine, making sure it wraps all of the I/O calls in asynchronous callbacks. Deployment is another thing that I've had to consider recently. We all know how to deploy applications in Ruby, generally using Capistrano for the pushing the code out, and maybe Puppet or Chef for managing our servers. Node doesn't really have many deployment tools built around it yet, so we actually ended up using Capistrano to deploy our Node applications as well. It doesn't mean you need Ruby on the server, you just have to have it on your laptop. CoffeeScript is another thing I wanted to mention. As Rubyists, we're probably all into the syntax of what we write, and we care about how our code looks. And CoffeeScript is kind of a little language that outputs JavaScript. So you're able to write your code in CoffeeScript, run it through Coffee, and either interpret it directly or have it output the JavaScript, which then can be ran later. So let's look at how we would go from, this is the URL shortener that I showed off before, and this is it in CoffeeScript. Notice that it doesn't actually remove any of the callbacks or anything like that. It simply tidies up the syntax, making it a little bit easier to read and removing all of the semicolons. So there's a bit of a gorilla in the room when it comes to asynchronous programming. Rails. Now, apparently, Rails loves you and hates you. And when it comes to asynchronous coding, Rails definitely hates you. It's a bit of a beast, and there's no at the moment, there's no consideration directly built into Rails for using it with Eventmachine. But Ilya Grigorek has been working on async Rails. It's kind of an experiment to see if you can make Rails asynchronous. And he's getting some interesting results from it. It's still early kind of work in progress. I wouldn't suggest you use it in production. But it's definitely something to look into, and kind of it'll teach you a little bit about how you can bring asynchronous programming into your code. So let's kind of try and shake out the differences between Node and Eventmachine. So something I hadn't mentioned before was that if you're writing your server-side code in JavaScript, then it does give you the ability to share code between the server and the client, which in some cases, especially if you're writing a very feature-rich front-end application, maybe written in Backbone or Spine.js or something like that, then being able to share code between the server and the client could be a real big win, something that we at the moment can't do with Ruby. There's also a vibrant community. People are really working hard to make Node a real choice when you come to building applications. And the V8 engine is pretty damn fast. But it is JavaScript. Lots of people, that would put them off straight away. It's hard to avoid callback hell. And it's only been around for 2 years, which compared to Eventmachine is not as mature, and there isn't as many kind of supporting aspects like being able to deploy it on onto a server is a kind of a lesser known entity, and you could have trouble potentially trying to deploy it. Eventmachine. So one of the biggest pros, I think, is that it's Ruby, and we all love Ruby, and it allows you to start working with asynchronous code without having to learn a completely different language and another programming style and another syntax. And you can also easily integrate it into your kind of current environments, maybe adding an Eventmachine application in with your standard stack and running it as a kind of a side for the extra performance when you need it. a lot more mature than Node, and has been around and kind of battle tested by lots of companies, including Pusher is a real big user of Eventmachine, and Confreaks Labs, as I mentioned before. It's got, with EM Synchrony and Goliath, some really nice kind of ways of fighting the callback hell and hiding that away in Ruby fibers, meaning that you don't necessarily have to consider wrapping everything in callbacks, which can make for a much more enjoyable experience when you're writing asynchronous code. And as we've seen, it can also be really fast compared to a synchronous application. You can get some real good throughput through it. But it's not as easy to write as normal Ruby. You need to consider that every I/O request could potentially be blocking the event loop and slowing your application down. And I found it to be a little bit more obtuse to write than, say, normal rack applications. But the benefits to writing asynchronous code are massive speed improvements. You're also restricted to EM libraries that work well with it. Otherwise, if you just throw in any old library, you could just degrade the performance completely. And it's not the new hotness, which Node is at the moment, which some people consider to be kind of important. They'll choose that when they go to build the next application just because it's the latest and greatest thing. An Eventmachine is not really in the news anywhere near as much. When I say news, I mean Hacker News. It's not considered to be as cool as Node, and that's not necessarily a problem when you come to write your application, but if you're trying to attract real talent to your business, then dropping Node in a job description can really make it stand out. So do I think Eventmachine is a worthy alternative to Node.js? Yes, I do. But one thing to remember is that neither Node or Eventmachine are magic bullets. You're not just going to be able to switch over to these things and it just solve all your scaling problems and you become web scale overnight. It's something that takes a different style of programming. Libraries like Goliath are able to simplify that a little bit, and you just have to remember that you are writing in quite a different way than perhaps you're normally used to. And if you are considering Node, there are some other languages which you might also want to look at. Go, Erlang, and Twisted for Python all bring a similar kind of asynchronous style and the performance that goes along with that. So Node isn't always necessarily the only other asynchronous language to use. Thank you very much.
Magically turn that off. Does anyone have any questions?
I'm still online. Okay, start with you. I noticed you attributed the difference in performance between Goliath and Eventmachine to its using fibers to convert syntax. And kind of following on from that, have you got any benchmarks for Synchrony? Does it
I haven't used EM Synchrony just on the top of Eventmachine yet. I jumped straight to Goliath because of the niceness that it kind of gives you. I would imagine that because Goliath adds in a number of default middlewares, that would slow your stack down as well, and EM Synchrony would alleviate kind of, I would guess, halfway between the two.
I just wondered if you had an example in your code of how you avoid the callback hell.
Yeah. Where's our Goliath example? So Goliath is actually automatically taking care of every time we write out to Redis. There was a pointer around here somewhere. every time we're saying, say, Redis set or Redis get, what's actually happening there is it's being pushed onto a fiber, and then when Redis comes back with the result or the error, it's coming back into context and taking over. But the code is just stopping there and waiting, and another request is being dealt with at the time.
So you can write procedurally.
So it looks procedural, but every time we go out to I/O, which in this example is every time we call Redis, it's actually a callback, and everything after it would have to be wrapped within a callback that you wanted to happen. So we can see that in the Eventmachine example, where I'm saying Redis set key URL, the result that it will send back is inside of that callback, whereas with the Goliath example, we just carry on, assuming that EM Synchrony underneath will take care of it for us.
Okay.
You said that testing in Eventmachine is difficult. What's it like for Goliath?
I didn't actually do any tests for Goliath, to be honest. The code was so trivial and small that I didn't have to I didn't test drive it when I wrote it. And it'd be quite interesting to see if you get the same kind of problems, or if EM Synchrony is able to alleviate some of that. I would guess you would still need to use the Eventmachine spec library to ensure that things are happening in the right order.
The microphone's out of battery, so if you can just project the question. Yeah, down in the front corner.
Yeah, do you think there's some benefit to having explicit callbacks, like being explicit about saying this code is going to execute at a later date, not now?
So it's definitely true that it's not obvious that we're going to be holding off whenever we call to I/O here, which if you're not experienced with using EM Synchrony or Goliath may catch you out. But the alternative of having in a reasonably large application many callbacks, I think the trade-off is worth it.
There was, I can't remember the name of it, and I've not done any Node.js programming, but there was something I saw that gave really nice syntax for avoiding callback hell.
Yeah, there is a couple libraries in Node that are kind of just starting to kind of come around and bring a similar way of wrapping the callbacks to give a synchronous style of coding. I haven't personally used any of those, and we don't use any in production at Forward either, so I didn't kind of investigate those further, but it's something to look into.
I think it's one called Node Promise. It does promises in Node. That's one of the ways to get around it.
Cool.
You mentioned the numbers for the second benchmark. Yeah, exactly. Did you try different Ruby implementations there?
No, I only use Ruby 192 there. It would definitely be interesting to see how 193 works and Rubinius. In the Goliath documentation, it says that Ruby 192 is currently the fastest implementation to run Eventmachine code on.
The back of the microphone.
One of the problems with racks is it's stack depth. Once you've got a route through Rails, you get down to what? It's about like 15, 16. Is that the same problem in Goliath, or is that using some kind of middlewares?
I would imagine so. It implements similar kind of methods, and I think it even brings in rack at some points as well, although I haven't experienced that myself.
Any other questions?
Is it true that you run the Node user group?
Troller's gonna troll. Yes, I've just, as I was getting into Node, I thought a good way to kind of learn more about it would be to start a user group, seeing as there wasn't one, and we basically copied lrug down to the name lnug. So I'm like, kind of like the Murray of lnug.
Any other questions?
Don't worry about the mic. Just a quick one. How does cramp relate to Rail and controllers?
So I only really threw cramp in there at the last minute. I believe you can make kind of cramp cramp controllers, which are ways of responding to different routes, but I haven't played with it enough to be able to kind of say more than that.
Anyone else?
I've got to do it because nobody else has. But isn't Node.js cancer?
You don't have to.
Well, if Node.js is cancer, then Eventmachine is the cure, or Chuck Norris.
Okay, I think that's probably a good place to stop. So,
Cool.
round of applause.